Okay, Calc, I'm gone today. These are your notes for section 3.2. This should be pretty short and sweet. It just kind of describes what a limit is. On your homework assignment, though, they will not give you the graph of this, and they will not give you the table, so it's something you kind of have to generate by yourself. So what they'll do to you is they'll give you this graph right here, and they'll say, okay, find the limit, and they'll write it this way, find the limit as x approaches 1 of this function right here. So they'll say x cubed minus 1 over x minus 1. So basically by doing that, they want you to find what's happening at 1, okay? And it would be really nice and easy if we could just plug 1 into this equation and evaluate it and find the value, right? But I can't plug 1 in because, like, 1 minus 1 will give me 0 on the bottom, and that's bad. So what I have to do is I have to look at the behavior on either side of 1. So what they've done here with the table here is they've plugged in numbers that are really, really, really close to 1. So they started here with 0.75, okay? And then they've got closer yet. I'll zoom in here. They've got closer to that yet. So they've started with 0.75, and then they said, okay, let's go even better than that. Let's go 0.9. And then they say, wait a second, let's go better than that. Let's go 0.99, let's go 0.999. And that's going to be awfully close to 1. We can't evaluate 1 exactly because it's going to end up with undefined. And then they started out here with 1.25, and it's like as they're going in toward 1, okay? They go in toward 1, and then they end up with like 1.001 is the last number that they plugged in. And so what we can see here is that 2.313, 2.710, 2.97, 2.997, and then coming in from the right side, basically what's happening here is each one of these numbers on either side is like pinching in toward the number 3. So the limit of 1, or as x goes to 1 of this function would be 3, because on either side of this function, we would have a value of, it's like pinching in toward the y coordinate. We're trying to find the y coordinate, which is 3. Okay, so finding a limit is like finding the y coordinate of stuff that we can't already evaluate. So we don't know where it's at 1, but we do know that if there was a place value that existed, it would be at 3. Okay, this is the graph of what he looks like, and you won't be given this graph, but this is just so that you can kind of see. So what's happening here is we plugged in numbers on the left side of 1, and we plugged in numbers on the right side of 1, and it's like really pinching in toward what this y coordinate is. Like, what is this y coordinate? And we found that it's really getting close to a y coordinate of 3 right here, okay? And so that's what the limit is going to be. So we're evaluating places that can't be evaluated, I guess, like where vertical asymptotes happen and where holes happen. So that's kind of what's happening here, okay? So this one is the same type of thing. They have it written in this notation. So what we're doing here is we're trying to find the limit as x goes to 0, okay? And we can't do that for this function because if I were to plug 0 into the bottom, 0 plus 1 minus 1, this would be the square root of 1, which is 1 minus 1, and I would end up with 0 in the bottom. And I cannot do that. That's bad. Okay, I don't care what my top number is. I cannot divide by 0. So we're looking at the behavior on either side of this number. So we started plugging in numbers that are really, really, really close to 0 on the left side and really, really, really close to 0 on the right side. So they started with negative 0.01 and negative 0.001 and negative 0.00001. And then they started with positive 0.01 and positive 0.001 and positive 0.00001 and whatever else. And they're seeing that the y coordinates are getting awfully close to a value of 2. So even though there's not a value that exists at 0 for this function, like there's a hole, you can see that, we can say that it's pinching in, and if there was a y coordinate, it would be 2. There's just a hole that exists there. So basically you are trying to find the y coordinate where the y coordinate does not exist. Okay, so like what is happening? Where should this be? And this should be a y coordinate of 2. It's pinching in here. It's pinching in here, and we notice that that value, if it existed, should be 2. Okay. All right. A couple more. So when you're given the graph, when you're finding the limit here, so they went ahead and graphed this for you, and they want us to find the limit as x approaches 2 here of this function, and this is really disgusting. This is a piecewise function. So this is saying when x equals 2, the y coordinate is 0. Okay, so when I'm going along here, and when the x coordinate is 2, the y coordinate is 0, so I have an open dot. And for all other values, for every other value, when x is not equal to 2, so when x equals 3, when x equals 4, when x equals 1, all other values, it's equal to 1. So it's going along, going along, going along, and then all of a sudden it like poops out here, okay? And it drops down below, and it's a y coordinate of 0. This would be like the scenario of like, you pay this much money, and then on your birthday exactly, you pay nothing, right? That's kind of like where that hole exists. Okay, so even though 2 evaluated, like it has a closed dot, even though the y coordinate at 2 is actually 0, the limit is equal to 1. Because we're looking at the behavior on either side, like what it's pinching in toward. So we're saying that pinching in toward this value, it should have a y coordinate of 1, because all of the places around it have a y coordinate that are close to 1, or 1 exactly in this case. Even though the actual answer to the y coordinate is actually 0, the limit, what it's pinching in toward, we're looking at the behavior on either side, it's pinching in toward a y coordinate of 1, so the limit is going to be 1. Okay? We're trying to figure out what's happening on either side of that number. Okay? All right, I hope this is all kind of making sense to you. All right, now, example 3. This is the Mean Girls, and if I was actually with you in class, I would actually play this video, but where she's sitting there in the quiz bowl, and she's like, oh, what was going on the board behind the really cute guy's head, whatever, and she says something about, the limit does not, if the limit approaches 2 different places, the limit does not exist. That's exactly what example 3 is, right here. If it approaches 2 different behaviors from either side, the limit does not exist. So it's asking for, this is a really disgusting function. The limit as x approaches 0, okay? So since we have the graph of this thing, we're going to go ahead and look at the graph of this guy. And what's happening here is as we approach, so this is the notation. The limit as x approaches, we're going to do 2 different scenarios. 0 plus, and the limit as x approaches 0 from the minus side. So absolute value of x over x, this is my function that I have. Absolute value of x over x, this is the other one. Okay, so we're going to look at 2 different scenarios. Rather than looking at the whole thing, we're going to look at, okay, this guy means from the right. When it's 0 plus, that means on the plus side of 0, which means on the right side of 0. 0 minus means on the left side of 0. Okay, so 0 is here. 0 lives here on this bar right here. Okay, and so what's happening on the right side of 0? We're coming in along our function. We're coming in along this line, right? And along the right side, he's coming in, looking like at 0, he's going to touch a value of 1. Okay? Now, coming in from the left side, zooming in here from the left side, he's going to approach a value of what looks like -1. Okay? So, what's happening is from either side, he's coming in, and it looks like he's going to touch 2 different places. And when that happens, when these 2 are not consistent with each other, then the limit does not exist, we say. Does not exist, okay? Because it has conflicting behavior on either side, okay? So if you reflect back from these guys, okay, when we're zooming in from the right side, when we're zooming in from the left side, they're both approaching the same value, okay? They're approaching the same point. Same thing here, approaching the same point. Here, same point. They're approaching the same point. But when they're approaching 2 different values, the limit does not exist. So that's kind of, we can't find a y coordinate because, like, they're in a fight with each other. Is the answer 1 or is the answer -1? So we just kind of give up and we say, nope, there's no answer. If you can't come to an agreement, there's no answer. Okay, and then there's another one here, which talks about, we'll do a left and a right side here. So they're asking for the limit as x goes to 0 of 1 over x squared. Okay, so I'm going to do the limit as x goes to 0 from the right. We'll look at him, and we'll say the limit as x goes to 0 from the left. Okay, so 1 over x squared, that's our function here, and 1 over x squared, that's our function. And we're trying to figure out the y coordinate. Again, that's what we're doing here, y coordinate. As we're coming in on the right side, as we're coming in on the left side. So this is from the right, because on the positive side of 0, that's the right side. Negative side of 0, that's the left side. All right, so we have our function here, and coming in on the right side. So we're coming in on the right side, we're going along this function, we're going along this function, and all of a sudden he like zooms up and up and up and up and up forever. Okay, so what y coordinate is he approaching all the way up here? Okay, well he's never going to stop. He's going to go on forever and ever and ever. So really we say that he's approaching a y coordinate of infinity because he's going to go on forever and ever and ever, up and up and up. Okay, now this one, coming in from the left side, left side, left side, left side, left side, I'm going in toward this 0. This is where 0 lives on the x-axis. Okay, x-axis, here's where 0 lives. So he's going up and up and up and up and up and up and up, and he's going to zoom on forever and ever and ever and ever and ever in the up direction, right? Same scenario. So what number up here is he approaching? Well, he's approaching infinity. Okay, now these two both are the same number. It's kind of a little bit different than this one because these ones were conflicting. These ones are the same number, but infinity is not technically a number, right? Okay, so, I mean, infinity could mean 100, if infinity could mean 1,000, could mean 1,000,000, whatever. So really, the answer to this one, even though these both are consistent, when it has an infinite limit, the limit does not exist. Okay, so those are two different types, or two different ways that the limits can fail. That's what this title is on the back side. Limits can fail. Limits can fail if you have conflicting numbers that it's approaching on either side, or limits can fail if it has an unbounded behavior, they call it, where it's approaching infinity on either side. Okay, so this limit does not exist. Now, I have a lot of people come test time, they will say, okay, the limit is infinity. And I won't count that wrong because technically infinity is the limit and it's consistent with both sides, left and right. It is infinity on both sides. So if you were to say this, I probably wouldn't count it wrong, but technically infinity is not a number that it's approaching, so the limit does not exist. It's not one number that's in existence that it's approaching. Okay, so that's why we say the limit does not exist. If you put limit as infinity, I probably won't count it wrong. Okay, all right, so let's go to these guys. These guys are really nice ones. So these examples, find the limit. Okay, so 4x plus 7, we're trying to find as x approaches negative 1. Okay. So, if I just think about, and you don't have to graph this always, but I'm just going to kind of illustrate this for you. 4x plus 7 means I go up to 7, whatever, and then I go up 4 over 1, up 4 over 1, and this is what my thing is going to look like. Okay, it's some linear function is what this guy is right here. 4x plus 7 is that line, okay? And they want to know what's happening at negative 1. Okay, negative 1 is this guy right here. So basically, I want to find the y coordinate. What is y at negative 1? Okay, well now, here's the really nice part. Negative 1, there's no hole there. There's no vertical asymptote. There's no skips or jumps or leaps or turns or anything like that. This is just a straight line. So, if I can, I might as well just plug this negative into the function. There's no holes. Why can't I plug it in, right? On this front side here, like I couldn't plug 0 in here because I would end up getting 0 in the denominator. Or I couldn't plug 1 in here because I would get 0 in the denominator. I can't plug negatives into square roots. But this one has neither of those. This one doesn't have a square root or it doesn't have a denominator, so I might as well just plug negative 1 in for x. So this y coordinate right here is going to be negative 4 plus 7, which is 3. Oh boy, and I was really not very good on my graph. This should be down here at 3. But anyway, the limit should be 3. So it's approaching a y coordinate of 3 if you can plug in. If you can plug it in. Plug it in. If you can plug it in, do it. Okay? There's no problems with that. I might as well just plug the darn thing in. It's when I have like 0 in the denominator or when I can't plug it in, that's when I have to look at the behavior on either side, like what it's approaching. Okay, this guy right here, the limit as x approaches 8 of the square root of 2x. Okay, so like square root functions, he looks like this, right? This is the square root of 2x. He might be a little bit taller or whatever, but I want to figure out as x approaches 8, what's this place right here? What's the y coordinate? Well, guess what? There's no holes, there's no vertical asymptote, there's no nothing. So let's just plug 8 in, plug it in. So the square root of 2 times 8 is the square root of 16, which is 4. This guy's going to have a y coordinate of 4. This is 8 comma 4. There you go. The limit is 4. Okay, so if you can plug it in, always plug it in. If you can't plug it in, that's when we have to do all this other like left and right-handed junk, or looking at the behavior on both sides, or making a table or something like that. Okay, so there you go. That's all that I have. I hope that all made sense. There you go.